Mars, a world that stares back at us each night like a red, unblinking eye. Its deserts are older than our oceans, its silence deeper than any abyss on Earth. For billions of years, this planet has been nothing but a grave of stone and dust, a frozen witness to time itself. Yet in that silence, there may be a secret, hidden not in ruins or monuments, but in something smaller, darker, almost invisible. A trace left behind, etched into the bones of Martian rock. A fingerprint that should not exist. Imagine it, billions of years ago, rivers once cut through these valleys, filling craters with deep blue lakes. The air was warmer, the soil richer, and perhaps something stirred within those waters. Something alive, tiny microbes clinging to survival, leaving behind waste, minerals, and patterns that would fossilize into eternity. Now, in September 2025, NASA's most advanced machine sends back an image. A rock, unremarkable at first glance, except for the strange spots marking its surface. Spots that look hauntingly familiar. Too familiar, like scars of life itself. If these marks are what scientists believe, then everything changes. Mars ceases to be the lonely twin of Earth. It becomes proof that life is not an accident, not a miracle, but a cosmic inevitability. And so the question is no longer, are we alone? The question becomes far more unsettling. Have we ever truly been alone at all? In February 2021, a small machine fell through the thin Martian sky. Wrapped in heat shields, slowed by parachutes, steadied by rockets, it descended into a crater that had been chosen with almost surgical precision. Its name was Perseverance, a rover built not just to explore, but to answer one of the oldest questions humanity has ever asked. Was Mars ever alive? Its landing site was Jezero crater, a circular scar more than 45 kilometers wide. From orbit, it appears unremarkable, just another basin among countless others. But its edges tell a different story. One side of the crater is broken, a breach carved long ago by flowing water. Ancient rivers once spilled through this gap, spreading into the bowl and fanning outward into a delta. To planetary geologists, this was more than a landscape. It was a promise. Where rivers once met still waters, sediments gathered, layer upon layer, preserving whatever lived or died in their currents. On Earth, such places are graveyards of fossils. On Mars, they might hold the same. NASA's pursuit of Martian life is not new. In 1976, the Viking landers touched down, armed with simple experiments to detect metabolism in the soil. The results were strange, tantalizing hints of chemical reactions, but not enough to prove biology. In 1996, a meteorite discovered in Antarctica, known as ALH 84001, ignited global headlines when scientists claimed it held fossilized microbes from Mars. Even President Bill Clinton stood before cameras and announced that history might be changing. But in time, that hope was dismantled. The fossils were revealed as mineral formations, non-biological processes sculpted into misleading forms. And yet, the dream never died. Jezero was chosen because it might finally offer what Viking and ALH 84001 could not: context. Rocks born in water, undisturbed for billions of years, waiting to be read like a book of ancient memory. As Perseverance rolled across the crater floor, its cameras scanned the horizon. It drilled into sediment, collected cores, and stored them in sealed titanium tubes for a future mission that might one day bring them home to Earth. But among its early images, one stone stood apart. It jutted from the sand, etched with dark, repeating marks. NASA scientists began to notice strange patterns, tiny specks like poppy seeds scattered across the surface, and larger ovals like leopard spots frozen in stone. To the untrained eye, it was nothing more than decoration, the randomness of geology. But to astrobiologists, it was something else entirely. On Earth, such patterns are often the shadows left by life itself. Microbes living in colonies, consuming organics, leaving behind waste that hardens into mineral scars. The rover's instruments turned toward this peculiar rock. Its cameras zoomed, its sensors measured, its drill prepared. The desert wind swept past, unaware that history might be hidden in this fragment of stone. And in that moment, the search for Martian life narrowed to a single image. A rock marked with scars that could change everything. When the images of the strange rock reached Earth, the first reaction was disbelief. Scientists had spent decades staring at Martian stones, each one shaped by wind and dust, each one carved by forces that seemed entirely mechanical. But this one was different. Its surface was alive with pattern, clusters of specks and ovals repeating in ways too deliberate, too organic to be ignored. Under the rover's instruments, the truth began to sharpen. Perseverance's spectrometers revealed the presence of two iron-based minerals hidden within the leopard-like spots, vivianite and greigite. On Earth, these minerals form not in the chaos of lava or the fury of heat, but in the quiet decay of life. They appear where bacteria consume organic matter, leaving behind mineral byproducts, signatures of once living colonies now long gone. To hold a Martian rock that whispers the same story as microbial fossils on Earth is both exhilarating and terrifying. Exhilarating, because it offers the first clear bridge between the red planet and the blue world we call home. Terrifying because it dares to suggest that life is not unique to Earth at all. But history tempered the excitement. Sherlock, mounted on the rover's robotic arm, bathed the rock in ultraviolet light, seeking the faint glow of organic molecules. And Supercam, perched high on the rover's mast, fired pulses of laser light to vaporize tiny fragments, reading their composition in the plume of energy left behind. The results were unsettling. Each instrument spoke of complexity. PyXL revealed iron clustered in strange concentrations. Sherlock confirmed organics, carbon-based molecules, the foundation of life itself. Together they formed a picture that could not be ignored. Minerals and organics intertwined, fossilized in the fabric of a stone 3 billion years old. The context deepened the intrigue. This was not volcanic rock, forged in fire and hardened by heat. It was sedimentary stone, formed slowly, layer upon layer, at the bottom of a once-flowing river. On Earth, such rocks are cradles of memory. They capture fragments of leaves, shells, and microbes, holding them for eternity. If life ever breathed on Mars, Jezero's sediments would be its silent tomb. And there, embedded in the stone, Perseverance's drill left its mark. A pale scar, circular and clean, cut deep into the surface and pulled out a core. Inside the hollow tube, dust and fragments from another world now rested, sealed against contamination, waiting for the impossible, a return to Earth. Someday, perhaps, these tubes may cross the void and fall into the hands of human scientists who could peer into Martian fossils not through cameras but through microscopes. For now, Perseverance carried only the tools it had, and those tools revealed more than anyone had expected. Not just organics, not just minerals, but patterns, textures in the rock that mirrored what biologists on Earth had long studied in fossilized microbial mats. Shapes that did not seem random, but deliberate, sculpted by processes that resembled life far more than lifeless chemistry. Each new observation added another thread to the puzzle, weaving evidence into something larger, something harder to dismiss. Organics where there should be none. Minerals that should not exist without decay. Textures that should not form without biology. And yet nothing was certain. For every sign of life, there was the shadow of doubt. Chemistry can mimic biology. Rocks can imitate fossils. Mars can play tricks that deceive even the best machines. Still, the deeper Perseverance looked, the less the mystery resembled geology, and the more it began to resemble memory. The memory of something that might once have lived, breathed, and vanished, long before humanity ever learned to look up at the stars. At first, it seemed like one more anomaly in a landscape already full of riddles. Mars has always teased humanity with illusions. Canyons that look like riverbeds, minerals that hint at oceans long gone, meteorites that whisper of life but dissolve under scrutiny. Yet this time, the patterns refused to fade. The more scientists studied them, the more stubbornly they clung to a biological explanation. What unsettled researchers most was not what they saw, but what they could not dismiss. Explanations were tested and discarded, one after another. Could the leopard spots have been burned into the stone by heat billions of years ago when the surface was violent and unstable? No. Vivianite cannot endure such temperatures. It would have broken down, destroyed before it ever crystallized. Could they have formed through the slow work of acidic waters seeping through the rock? Again, the evidence rejected this. In the very same sample, minerals like olivine were preserved, and olivine dies quickly in acid. The rock itself seemed to argue against its own innocence. That left only one interpretation still standing, one that grew more haunting with every test: the possibility that these marks were microbial scars, ancient colonies that once consumed organics in the cradle of a Martian river and left behind the waste of life, fossilized in silence. If true, the implications stretched far beyond a single crater. It would mean Mars remained habitable for longer than Earth's scientists had imagined. Not a brief, fleeting chance, but a wide window of time when rivers carved valleys, when lakes filled basins, when conditions mirrored those of a young Earth. On both planets, life may have sparked in parallel, fragile microbial civilizations rising unseen in the shallow waters of two worlds. The thought chills the imagination. While Earth's first forests reached for the sky, perhaps microbial communities on Mars still clung to existence, hidden in its rivers and soils, before fading into extinction, life and death echoing across planets, separated by silence yet bound by the same cosmic chemistry. For NASA, the mystery deepened into something almost unbearable. The evidence pointed one way, the burden of proof another. Announcing life would be monumental, but being wrong would shatter trust, as it had in 1976 and again in 1996. And so, each discovery became a double-edged blade. Proof was close enough to touch, yet still veiled in doubt. Mars had become more than a neighbor. It had become a mirror, one that reflected our deepest fear and hope, that life is not singular, not miraculous, but universal. If microbes once thrived here, then the cosmos is not empty, it is alive. And yet the Martian desert remains silent. No rivers flow now, no microbes can be seen. Only the marks endure, dark, stubborn patterns in a stone, daring us to decide whether they are the echoes of life or the greatest illusion ever carved into rock. The leopard-spotted stone in Jezero crater became more than a geological curiosity. It became a canvas upon which humanity projected its deepest theories, explanations drawn from the frontiers of science, from the ancient story of Earth, and from speculation that stretches beyond the edge of our universe. The first and most grounded interpretation is also the simplest. These spots are the fossilized remains of ancient microbial colonies. On Earth, microbes once ruled shallow lakes and riverbeds, forming thin mats that consumed organic matter and left behind mineral waste. Over time, their communities etched themselves into stone, silent testimonies of a vanished world. Could Mars have followed the same script? If so, then Perseverance may be staring at the first page of a Martian fossil record, a record that began billions of years before human eyes were ever capable of seeing it. But another possibility emerges from the violence of the cosmos. Some scientists argue that Mars may never have birthed life on its own. Instead, life may have arrived there, delivered by asteroids carrying organic molecules. This theory, known as panspermia, suggests that planets trade the seeds of biology across the solar system. A comet striking early Earth may have splashed fragments into space, some of which landed on Mars. Or perhaps the journey went the other way. that Earth's spark came from Mars itself. If either path is true, then life is not confined to a single cradle. It is migratory, restless, scattered across the void. Others propose a darker origin. Could the organics in Jezero's rock be nothing more than chemistry, lifeless, intricate reactions that mimic biology but never cross the threshold into it? This line of thinking is not without merit. The history of Mars is filled with false dawns, where geology masqueraded as life. Skeptics warn that the same story may be repeating now, yet speculation does not end with caution. Some physicists lean into the broader canvas of the cosmos. If life emerged both on Earth and Mars within the same cosmic neighborhood, then perhaps life is not a rare miracle at all. Perhaps it is woven into the very laws of physics, as inevitable as stars forming from gas, as natural as rivers carving valleys. Einstein once said that the universe is comprehensible because it obeys laws. Hawking pushed further, suggesting that given the laws of physics, life is almost certain to arise wherever conditions allow. Mars may be the second verse in a song the cosmos has been singing since time began. And if microbes once lived here, perhaps they never fully died. Some scientists speculate that deep beneath the Martian surface, shielded from radiation and frozen cold, remnants of biology may still endure. Not as thriving ecosystems, but as survivors, microbes clinging to subterranean ice or ancient aquifers waiting to be uncovered. In the end, speculation widens rather than narrows. Whether Mars was seeded from Earth, born of its own chemistry, or still harbors hidden life, the implications are the same. If life happened twice within one solar system, then it will happen everywhere. The universe then is not a void, it is a garden. The mystery of Jezero's spotted stone cannot be solved by images alone. To move from possibility to proof, science must push its tools to their limits, and perhaps even beyond them. Perseverance was built with that mission in mind. It is more than a rover. It is a mobile laboratory carrying the most advanced instruments ever placed on another world. Its cameras read the terrain with the clarity of human eyes. Pixel scans the chemistry of Martian rock at the scale of dust, painting maps of elements with X-rays. Sherlock, with its ultraviolet light, makes organic molecules glow faintly in the darkness. Supercam fires bursts of laser energy, vaporizing grains of stone to reveal their hidden signatures. Each tool adds a fragment of truth, a sliver of evidence. Together, they compose a mosaic of mystery, iron minerals, organics, and patterns that whisper of something more. But Perseverance carries another gift, one that looks beyond its own lifetime. It is a collector. Within its frame rest 27 titanium tubes, each holding a core drilled from Martian rock. These tubes are not for today, nor for Perseverance's cameras. They are for tomorrow, for a mission yet to come, when humans will attempt the impossible, to bring fragments of Mars back to Earth. The plan was bold. NASA and the European Space Agency once dreamed of a Mars sample return, a relay of machines, a fetch rover, a rocket, an orbiter, working together to lift Perseverance's sealed cores off the Martian surface and carry them home. In laboratories on Earth with instruments of unmatched precision, scientists could search for isotopes, proteins, or microstructures that no rover could ever confirm. But politics and budgets weigh heavily. The mission remains uncertain, its timeline slipping into shadow. Meanwhile, another player prepares its move. China has announced its own Mars sample return, with a mission scheduled for 2028, aiming to return to Earth by 2032. Where the United States hesitates, China accelerates. The rivalry now extends beyond geopolitics. It has reached into the search for life itself. The first nation to return Martian samples may also hold the first undeniable proof of extraterrestrial biology. Beyond Mars, the hunt widens. Telescopes orbiting Earth, like the James Webb Space Telescope, search distant exoplanets for the chemical breath of alien atmospheres. Missions to Europa and Enceladus prepare to pierce the icy shells of moons where oceans may conceal living ecosystems. Instruments aboard future probes may taste plumes of water erupting into space, searching for amino acids or microbial traces. Each machine, each mission is a hand extended into the dark, reaching for answers. Perseverance is only the beginning, a single step in a longer march. To solve the mystery of the leopard spots, science must bridge the distance between two worlds, carrying not only tools and samples, but the weight of humanity's oldest question. The search does not end with Perseverance's wheels in Jezero's dust. It continues in the dreams of telescopes, rockets, and the relentless curiosity of a species unwilling to accept silence as the only answer. Mars lies silent beneath its pale sky. The rover's wheels carve shallow tracks into dust that has waited billions of years for a witness. Around it stretch ridges and plains where rivers once shimmered and lakes once gathered, their waters long since vanished into the frozen ground or the thin, breathless air. Nothing stirs, and yet, within these lifeless stones may rest the most profound truth humanity has ever sought. If microbes once lived here, then life is not rare. It is not the fragile miracle of a single blue world orbiting a single star. It is a principle, a pattern written into the universe itself. Where water flows, where organics gather, where energy sparks, life emerges, small and unseen at first, but inevitable as gravity itself. What does that mean for us? It means that the question, "Are we alone?" was never the right one. The deeper question, the unsettling question, is whether life is everywhere. If Earth and Mars both knew biology, then the stars above us may not be silent at all, but crowded with living worlds, each with its own stories, its own struggles, its own fragile breath. For philosophy, it is a challenge. Humanity has built religions, histories, and cultures on the belief in its uniqueness. But if microbes once thrived on Mars, then existence itself is shared. The cosmos is not an empty stage built only for us. It is a vast ocean, and we are but one drop among countless others. And yet, proof remains elusive. The tubes of Perseverance sit scattered across Jezero's desert floor, waiting for a mission that may never come. Budgets shift, politics intrudes, and the fragile chain of discovery hangs in doubt. Perhaps China will succeed first. Perhaps NASA will find the will. Or perhaps the rocks will remain there for centuries, their secrets sealed until another age. The evidence is within reach, yet still beyond our grasp. A truth suspended between ambition and hesitation. So we are left with silence. The Martian desert waits, indifferent to our urgency. Its stones hold their secrets patiently, for they have already outlasted oceans, atmospheres, and eons of time. To them, decades of human delay are nothing at all. But for us, the wait is enormous. Humanity has gazed at Mars for millennia, imagining gods and civilizations, yearning for neighbors in the sky. Now we stand on the edge of an answer. And perhaps the answer is not grand empires or intelligent voices, but something far smaller, more delicate. The fossil of a microbe, the trace of a colony, the scar of life in stone. And in that scar lies everything, the proof that we were never alone, that life is not an accident, but a destiny woven into the cosmos. The truth does not shout from the heavens. It waits quietly, not in distant galaxies, but in the silent dust of our nearest world.